So you got Unit 4, Lesson 1, okay, powers with whole number exponents. So in this unit, we're going to review the powers with whole number exponents where the base is a numerical. We extend these concepts into powers with bases that have a variable. So we're going to start with just numbers, and then we're going to move on to variables, okay? In this lesson, we'll review powers and all that stuff from grade 9, okay? So let's just, exponents. In mathematics, exponents are used as a short way to write repeated multiplication. The number of small cubes in a diagram can be calculated by repeated multiplication of 2 by 2, because this is a 2 by 2, and then the height is 2. Okay? 2 by 2 by 2. So you can represent it as 2 cubed, which would be 8. There's 8 total cubes in there. That's where the term cube comes from. Okay? When you're times something by itself 3 times, you're doing a cubic version of it. Okay, same thing here. Exponents can also be used with variables. If we don't know what a is, we can represent this still as a cubed is the volume of this cube right here. Okay, variables can have the same properties. Okay. Questions so far? We're just reviewing, hopefully. Okay, so then we should know this from grade 9 really well because we're actually doing this right now, grade 9. Okay, a power is a number written in exponential form. So remember, the whole thing is a power. A to the n is a power of what? If I say a to the n, that's a power of what? A, the base. Because it's a power of the number that you're multiplying by itself. Okay, so if I say a to the n is a power of a, okay, so this right here is a power of 4 to the 5th. But anyways, the whole thing's called a power. The base is the number that's being repeated, and the n tells you how many times it's repeated, or how many times it's multiplied by itself. Okay, so state the base and an exponent in each of the following. So base, everybody understand 4? Okay, your exponent is 5. Okay, base for part B, -3, exponent, 6. C, base, x, exponent, y. Okay. Simple, simple. All right, so now we have to go remember the exponent laws. Okay. Oh yeah, forgot. My notes have a page missing, so. All right, so number of multiplied variable is called the coefficient. So the number in front, remember, is a 7 being cubed? No, remember, the 7 is not being cubed unless there's parentheses there. If there's parentheses around both, then the whole thing will be like a package to be being cubed. Right now, just the p is being cubed, so we call this our coefficient as 7. Okay, your coefficient is a number in front of your variable. Okay, so coefficient, so right here, if we set the coefficients, so Tatum, what's the coefficient of this one? 8. 8 is the coefficient of my x squared. Okay, Janae, what's the coefficient of this one? The -3. Okay, oh, great. Brandon gets the hard one. C, what do you think it is? Close. 1/7. Because right here, this is the same thing as this. Like that 1/7 that just comes in, so it's 1/7. Whoops. 1/7 would be your coefficient there. Okay. Note that the written repeated multiplication, so that's how we would write it if you did repeated multiplication. It'd be 7 with 3 p's. Okay? So then here's the difference. 7p cubed would be 3 7p's, okay, which would be a lot different. Excuse me. Okay? All right, example 3. Okay, and if I'm going too fast, let me know, because I know this is somewhat review, but if you need some clarification, feel free to stop me. Holy moly, what? This only does this on this book, I swear. Where are we at here? We're on page... Okay, thank you. I don't know why. Maybe if I max it out. Alright. So each of the following is repeated multiplication. So this helps you understand, the reason we're doing this section, this helps you understand what's being, what has an exponent and what doesn't. Okay, if you have a variable with nothing up here, an exponent, what is it? Just a 1, or yeah, just a 1b, that's correct. So if I write this out, it's going to be 1, 3, 4 a's, and 1b. Okay, the next one, 1, 3, 4 ab's. This is good, kind of showing the difference of all 4 of these, because they all look somewhat similar. Okay, and then part B, 1, 3, 1A, 4 B's. There, I got 4. Okay, and the last one, the whole package is to the 4th. That's going to give you 4 3's, 4 A's, 4 B's. Okay. Yep. 3AB 4 times is fine. Okay, evaluating powers. 10 times 10 cubed would be 1,000. Evaluate means find the value. Okay, 3 to the 4th. Anybody know what 3 to the 4th? 81, good. 3 cubed is 27, so 3 to the 4th is 81. Negative 6 squared. What's a negative 6 times a negative 6? The positive 36, right? It's a negative, but it's an even exponent, so we're landing positive. Okay, it's a negative with an even exponent. Now, look at the difference between the far right and the bottom right there. Okay, the negative on the bottom right is not in what? It's not in brackets, so that negative is not being squared. That's why when they're doing it here, it's just hanging out. Essentially, it's not being bothered by the square. So what that pretty much means, the way I think about it is, if you have a negative hanging out, it means opposite of whatever you're going to get squaring it. You can't say it's always in positive or negative. That's not going to work. All you can say is it's going to be opposite of whatever your answer is. So if I cover this up, 6 squared is a positive 36. We want opposite of that, so we get a negative 36. The reason I'm saying you can't say positive or negative is because what if I did this? What if I do... It'd be a negative, right? Okay. What if I did this? They don't when the bracket's here, because what's first in order of operations? Brackets. You have to square first and then hit the negative. So that makes it a 36, negative 36. Now look at this one. Negative 2 cubed. What's negative 2 cubed? Negative 8. And then a negative makes it positive. See what I'm saying? Think opposite. Don't think a positive or negative. Don't do that. Okay. Any questions on that? We sure? We need to have some more questions. All right. Okay, moving down here, the 0 exponent. What did we learn about 0 exponent last year? Yes, you remember. Okay, 0 exponent equals 1. For those of you that didn't have me, or you may not, you were never told maybe, this is why. We know that, let's just talk about this, 3 cubed over 3 squared, we go 3 minus 2. That's the exponent law with quotient. We minus the exponents, right? And the reason that is because we have 3 3's on top, and we have 2 3's on bottom. So we cancel them. We're left with a 3 to the 1, which is 3 minus 2. Okay, that's the quotient rule we were supposed to learn last year. Well, the reason there's a 0 is this. If I change the 3 squared over 3 squared, well, let's just think about this. What does 3 squared equal? It equals 9, right? So it's 9 over 9. What's 9 over 9 equal? 1. What's 2 minus 2? 0. So that's the proof of why to the 0 power is 1. It's not 0. A lot of people think it's 0. Okay, does that make sense? Yeah. Cool. So evaluate the following. All these are 1. This is a negative 1. And 2. So this one's a negative 1 because that negative is not being hit by the 0. The 2 is not being hit by the 0, so that's a 1. The 2 just stays a 2. All right. We good? Okay. scared now. So exponent laws here. So this chart below tells us all of our exponent laws. So, in review, this one is called the product of powers law. When you're doing product of powers, they have to have the same base, and you can add the exponents. Important word there is they have to have the same base. If this was a 6-3 and an 8-2, we couldn't do anything because they're different bases. Okay? So then all we do here is we add the exponents. So the rule is a to the m plus n. Okay? A to the m plus n. Again, that's because we have 5 of them. 1, 2, 3, 4, 5. We add them all up. Okay, then as I talked about a second ago, when you're doing division of powers, do the same one. A3 over A2, essentially they cancel. You're left with a A1. Okay, or you can write that as a to the 3 minus 2. Or a to the 5th and 3 plus 2. Okay. A to the 1, 3 minus 2. And the rule's already here for us. Oh, no, it's not. A to the m minus n. The top minus the bottom. Okay, power to power rule. Okay. Or no, power to product, excuse me. Not to power to power yet. Power to product. So, if you have 8 times 7 to the third, that means you have 3 8s and 3 7s. Okay, that means it hits both of them. So it's 8 times 8 times 8, 7 times 7 times 7, 8 cubed times 7 cubed. Okay, so the word in terms of variables, same thing. B times B times B, B8 cubed, B cubed. So your power product rule is, if it's AB to the m, it's AM, BM. Alright, couple more. Is anybody forgetting of these rules at all? They're all kind of just refreshed. Okay, let's talk about power of quotient. A power quotient should hopefully ring a little bit of a bell because it should be, it's kind of similar, you hit top and bottom. That's the basic rule. So 8 over 7 cubed means you have an 8 and a 7, 8 and a 7, 8 over a 7. You have 3 of them. And when you multiply fractions, you multiply what? Straight across. So you really have an 8 cubed over a 7 cubed. So you cube the top and the bottom. Very similar relationship that we did with our warm-up, or excuse me, the quiz with the radicals. If you cube root a fraction, you're cube rooting the top and the bottom. Okay, so then here again, it's A, B, 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 cubed, cubed. So power of quotient law is A over B to the n is A to the n over B to the n. B can't be 0 because we can't divide by 0. I like exponents because they're very straightforward. It's got a set of rules and you have to follow them. Okay, power to power. Okay, so power to power. A lot of people get this one and the first one mixed up. They're different. Okay, power to power is when you have an exponent with another exponent to it. Okay, and what that means is I have 8 cubes squared. That means I have 2 8 cubes. Okay, so 2 8 cubes would be 2 sets of 3, which would be 2 sets of 3 is how many 8s total? 6. Okay, or 8 to the 3 times 2. So the rule with power to power is you multiply the exponents. 3 times 2. Okay, so write this one out too. We got 3 A's, 3 A's. So we got a to the 6 or a to 3 times 2. And our actual definition rule is a to the m times n. I put a dot there for multiplication. You can write just mn if you want. Okay, good refresh. Okay, let's go ahead and just finish this up. We've got a couple more, I think. Alright, right here, just these 2 examples. And we'll be done. Alright, so use the exponent law, simplify, and then evaluate. So we're going to put these together as one exponent, and then we're going to calculate in our calculator. So 3 to the 4 times 3 to the second. They're the same base. Which rule is this? Yep, the addition rule. It's the product of powers. Okay, so 4 plus 2 is 3 to the 6th. And then what does 3 to the 6th equal? 729. Thank you. 729. Okay, this one, which rule? Subtraction, the quotient. So it's going to be 5 minus 3. They have the same base. Negative 2 squared. So we should get 4. Positive. And the last one is our power product. So it's going to be 5 to the 6th, which is a pretty big number. What's that going to be? Say it again, Janae. 15625. 15,625. All right, good. Should have enough, I think, for everybody to do one here. So we're all going to go around and do one. All right, so we'll start with Tatum. Tatum, what is part A going to be? Good. A to the 7th. Good. Product of powers. Okay, good. Janae, what is B going to be? X to the 7th. Okay, it's still product of powers. Good. Brandon, what is C going to be? B11. Good. The zeros are relevant, right? Okay, good. Mike, D? X to the power 4. Good. Okay, we'll come back to Josh here. Y to the power 8. Good. Molly? A to the 12th. This is power. Good. And Allie? Right here on G. Yep, 5 times 5. Good. Y25. Okay, Chris, the fraction one. Good. X9, Y9. Hits 9 hits both top and bottom. Very good. Breezy? I? Yeah. Yep. Okay, and we can make that a 16 if we want, but that's okay. We'll leave it like that. Alex? Okay. No plus, right? Yeah. T6. Okay, good. S6 times T6. Okay, good. Jose? 2 to the 5th, A to the 5th. Good. And Taylor? What's that? Yeah, P and Q are both. Okay. Oh, is it one? No, they're yeah. P to the 4th, Q to the 4th. Okay, good question. Sorry, I didn't understand it at first. Okay, so, and then make sure you do the -3. You have to have the brackets. That's important. Okay, if you don't, you'll miss it. Okay, your answer will kick out a negative. All right, that's it for today. Okay.